Hey guys, my name's Ashley. Welcome to my final presentation on antibiotic resistance. So, to understand this issue, you first need to understand what antibiotics are. Antibiotics were discovered or invented in the early 20th century by Alexander Fleming, who was breeding various forms of mold. Fleming called his medicine penicillin after the penicillium mold it came from. Antibiotics like this work by directly fighting a bacterial infection to eliminate it, or by weakening it enough that the body can finish the job. The discovery of antibiotics greatly reduced the amount of deaths arising from bacterial infections and extended lifespans. So, what happens when, after all this time we've been using them, these meds become ineffective? Bacteria are the most successful life forms on the planet, and have been since the beginning of time. They're the largest forms of life in terms of biomass, and outnumber our own human cells 10 to 1. As a matter of fact, 1 square centimeter on your skin contains most likely around 100,000 separate bacterial cells. Not all bacteria are bad, some are downright beneficial to us, but some forms of bacteria are responsible for the worst diseases known to man. So antibiotic resistance is really not something to be taken lightly. One way antibiotic resistance happens is through the overuse of antibiotics. While they used to be exclusively for medical issues, antibiotics were found at some point to have the ability to promote growth and increase feed efficiency in food animals. They began to use regularly, not for infections, but to increase profit in the agricultural sector. Because they were used so frequently, antibiotic-resistant bacteria became abundant in the guts of these animals. Then, they would expel the bacteria in their feces, which would contaminate something humans consume. Those bacteria can then populate the bodies of humans, where they remain resistant. In 2017, the CDC said that was inappropriate use of these meds, and it has reduced the usage of them in this manner. The FDA even requires a veterinarian to be present if antibiotics need to be administered in animals for a legitimate medical reason. Another way resistance can happen is through the misuse of antibiotics. Maybe you think you have pneumonia, so you go to your doctor and ask for antibiotics. But they're busy, and they prescribe them to you to save time. Actually, you might have a cold or flu, both of which are viral. Antibiotics don't work against viral infections, so taking the meds would do nothing except kill off your good bacteria and leave the resistant bacteria behind to reproduce. Another person might actually need antibiotics, but they stop taking them as soon as they start to feel better. The antibiotics defeat the weakest bacteria first, but if the meds stop coming, the resistant bacteria make a strong comeback and pass on their resistance to the next generation. This is such a problem that 35,000 people a year die from complications arising from drug-resistant bacteria. We're now seeing that some infections we consider to be curable are more difficult or even impossible to cure. Multiple drug-resistant strains of bacteria are found in every country of the world. In Africa, 80% of the bacteria Streptococcus pneumoniae, which causes pneumonia, tested resistant to penicillin, the main treatment against it. Even 10 to 20% of some strains of gonorrhea are resistant to penicillin and tetracycline, which is another type of antibiotic. Even some fungal infections can no longer be treated with these meds. Beyond the obvious medical implications, drug-resistant bacteria happen to cost the US billions of dollars annually. Alright, so what do we do? We've already stopped using antibiotics in food animals for non-medical uses. While doing that has helped the problem of resistance, it's also increased the number of pathogens that are reaching us through our food. However, if we can begin to treat those issues with our antibiotics again, the trade-off might be worth it. We can also provide incentives for the pharmaceutical companies to develop new drugs. Right now, they don't focus on that, since it isn't where the money is. Sometimes regulations get in their way as well. However, even if they start development now, it could still be 10 years before we see a new drug viable for human use hit the market. Better start now. We've also started having doctors and nurses around the world visually confirm their patients are completing their antibiotic courses. Also, one of the best things we can do is educate our communities about this problem, to empower the citizens to make informed decisions for themselves. Communication plays a key role here, especially toward those who may be illiterate and don't understand. The main goal in combating antibiotic resistance is to detect, stop, and prevent the emergence and spread of resistant bacteria. Officials look to the One Health model to help develop plans to solve problems such as this one. One Health takes into consideration the world's people, animals, and environment as a way to see things holistically. It's been adopted around the world to promote the world's health. Part of the One Health model is bringing the world together to help us all make better decisions about our health. In 2018, the CDC and the Department of Health and Human Services partnered with more than 100 companies and organizations to help solve this problem. They created the Antibiotic Resistance Challenge, and the governments of Finland, Pakistan, India, Japan, and Nigeria all signed on to help. They're all working on ways to reduce antibiotic resistance by improving prescribing practices, preventing or controlling infections, developing new vaccines or drugs, and creating new diagnostic tests. It's a huge undertaking, but definitely a good place to start. Another thing that's being done is figuring out how to treat these bacterial diseases differently. One method, in the case of tuberculosis, is to combine anti-TB drugs together to cover a spectrum of MDR strains. That way, some of the drugs work on some of the bacteria, and some drugs work on the other bacteria. Doing this even led to breakthroughs in treatments for HIV, leprosy, and some forms of cancer. We can also cycle through antibiotics we use predominantly, which allows bacteria to become resistant to that one drug, then switch what we use so that the new drug is unfamiliar to the next generation of bacteria, and it works again. Even though this is such a huge issue now, the situation is not all without hope. We have a lot of really brilliant minds working on the issue, and all it will take is one new discovery for a considerable breakthrough. That's another reason why saving the environment is an important issue. You never know when a newly discovered plant, fungus, or animal will be the new savior of mankind. If it all disappears, we'll never know the potential. Thank you guys so much for viewing my presentation. I hope you learned a little bit more about antibiotic resistance. Please look to my references for more information, or feel free to contact me if you have any questions.